Hi, today we are going to talk problems related with motion of bodies in a plane. Already we saw motion of bodies in a straight line, the related problems. Now we are going to see motion of bodies in a plane. So for that, we should know something about what are scalars and vectors, what are scalar product and vector products, formula, parallelogram law of vectors, formula, basic things, basic formula alone. Physical quantities which possess only magnitude are called scalars. Mass, length, time, work done, power, all these things depends only on magnitude. So they are called scalars. Physical quantities which depends both in magnitude and direction are called vectors. Force, acceleration, momentum, all these things, vector quantities. Scalar product of two vectors, that is otherwise known as dot product. A vector dot B vector is modulus of A modulus of B cos theta. Vector product of two vectors, A vector cross B vector is equal to modulus of A modulus of B sin theta n cap. In the case of scalar product, the resultant is a scalar. In the case of vector product, the resultant is a vector. To indicate the direction, we are multiplying with a unit vector. So n cap here is a unit vector. Okay. The direction of unit vector will be perpendicular to A and B. Two vectors A and B, perpendicular direction. Say vector A and vector B, you want A cross B clockwise. So resultant will be downwards. B cross A, the resultant will be upwards. Corkscrew rule, right hand thumb rule. So rotate, when I rotate the screw, the direction of screw which is advancing will be downwards. Release the screw, screw will come in the upward direction. So anti-clockwise upwards, clockwise means downwards. Thumb rule also same. Curling of finger is anti-clockwise. See the thumb direction upwards. Curling of finger clockwise. Thumb direction is downwards. Right hand thumb rule, which indicates the resultant direction in the case of vector products. Scalar product example work done. W is equal to F vector dot S vector. Here torque R cross torque, displacement, force, all the three are vectors. Force and displacement are vectors, but work done is a scalar. Okay, fine. Next. Projectile motion. Before that, we should know something about equations of motion that already we know. V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AX. In the case of vertical upward or downward motion, for upward, A is replaced by G. Since it is moving against the gravity, G is negative. Downwards means G is positive. Already we have seen this concept in the problems related with motion of bodies in a straight line. So A replaced by G, upward means minus G, downward means plus G. Okay. Parallelogram law of vectors. P vector, Q vector. This is resultant or parallel to this P, one more, parallel to Q, one more. So this is parallelogram law. Resultant is root of P square plus Q square plus 2PQ cos theta. Alpha is the angle between the resultant and the vector P. So tan alpha is equal to Q sin theta by P plus Q cos theta. Resultant in the case of parallelogram law vectors. Resultant direction means tan alpha. Theta is the angle between the two vectors P and Q. This is theta. This is Q. This is theta. This is theta. This is, these two are equal in path. Okay? Fine. So in projectile motion, body projected from top of the building, body projected from horizontal ground. Depending upon the case, we can simplify the problem. So with this base formula, we will go to the problems. First problem, a body is simultaneously given two velocities, one 30 meter per second due east and other 40 meter per second due north. Find the resultant velocity. First problem. Two directions. Body is given simultaneously 30 meter per second due east. This is east, this is north. A, B, this is O. VA, VB. Resultant will be OC. Angle between them is theta. This is resultant velocity. So from the diagram, it is very clear that V is equal to root of VA square plus VB square. Straight formula. So I can write what is VA? 30 square. This is 40 square. So root of 2500. 50 meters per second. Resultant velocity will be 50 meters per second. Suppose resultant direction they are asking you to calculate. Resultant direction is tan alpha. Q sin theta. So in this case, theta is the angle between A and B. This is alpha. So tan alpha means, parallelogram means you can use the formula AC by AO. Opposite side by adjacent side. AC is nothing but VB. This is VA. So VB is 40. This is 30. 1.333. So you have to take logarithm book. In that natural tangents you take. In natural tangent side, tan 45 is 1. We are getting 1.333 here. So the angle should be more than 45 degree. So in natural tangent side, 0 degree to 90 degree it will be there in the table. So you verify for what value corresponding angle. Generally, angle will be given value of the calculator. Here value is calculated 1.333. Corresponding angle we have to find out. So if you see the logarithm book, the answer is 53 degree 8 minutes. 1 degree is 60 minutes. 0.1 degree means 6 minutes. Okay, so this is first problem. Second one, two forces 5 Newton and 7 Newton act on a particle with an angle of 60 degree between them. Find the resultant force. 5 Newton and 7 Newton, angle 60 degree. Directly they have given root of p square plus q square plus 2pq cos theta. What are the values of p and q? 5 Newton and 7 Newton. Root of 5 square plus 7 square, 2 into 5 into 7. 60 degree angle. So that should be cos 60 degree. So R is equal to root of 25 plus 49 plus 10 into 7. Cos 60 is what? 1 by 2. 2 cancels. So 35. 74 plus 35. Root of 109. Root of 100 means it should be 10. It is root of 109. Slightly more than 10. 10.44 Newton. This is resultant. Resultant is making an angle alpha with respect to P. Also, tan alpha is equal to Q sin theta by P plus Q cos theta. Q sin theta by P plus Q cos theta. Q 7. What is the angle given, man? 60 degree. Sin 60 by 5 plus 7 cos 60. Sin 60 is root 3 by 2. Cos 60 is 1 by 2. Simplify, you are getting 0.7132. See the natural tangents, the value is around 35 degree, 29 minutes. 35 degree, 29 minutes. Third problem, two equal forces have the resultant equal to either. What is the angle of inclination? Basic formula for resultant is root of p square plus q square plus 2pq cos theta. Here the resultant is equal to either two equal forces. That means what? P is equal to Q is equal to R. That means P is equal to root of P square plus P square plus 2 into P cos theta. Root of 2p square plus 2p square cos theta. Square both sides. P square means root will go off, take 2p square outside, 1 plus cos theta. Cancel. Cos theta is equal to minus 1. Minus 1 by 2. Cos 60 is half. So, one more rotation, minus sign. So, theta will be 120 degree. Half means 60. Another rotation. So, 120. Correct? Fourth problem. Two forces whose magnitudes are in the ratio 3:5 give a resultant of 35 Newton. If the angle of inclination be 60 degree, calculate the magnitude of each force. P is equal to Q is equal to 3:5. So this is 3x, that is 5x. Value not given. Resultant is 35 Newton. Angle of inclination theta is 60 degree. Therefore, R is equal to root of P square plus Q square plus 2PQ cos theta. 35 is equal to root of P square, 3x square, 5x square, 2 into 3x, 5x cos 60. So 35 is equal to root of 9x square plus 25x square plus 6x into 5x, 30x square. Cos 60 means half. Root of, this will be 15, 40, 49x square. That is 7x. The x is equal to 35 by 7. 5 Newton. 5 Newton. You have to calculate the individual force. Individual force value not given. The ratio only given as 3:5. So therefore, P is equal to 3x. 3 into 5, 15 Newton. Q is equal to 5x. 5 into 5, 25 Newton. Correct? So this is fourth problem. Fifth problem. Calculate the angle between a 2 Newton force and a 3 Newton force. So that the resultant is 4 Newton. Simple. Straight from formula. Root of P square plus Q square plus 2PQ cos theta. Even though the formula is same, different concept they are giving. R is 4 Newton. This is 2 Newton. This is 3 Newton. Angle between them. That's what you have to calculate. So 4 is equal to root of 4 plus 9 plus 12 cos theta. 13 plus 12 cos theta. Square. 4 square is equal to 13 plus 12 cos theta. 12 cos theta is equal to 16 minus 13. Cos theta is equal to 3 by 12. 1 by 4. 0.25. 0.25 corresponding angle in natural cosines. Logarithm book, natural cosine, natural tangents, logarithmic tangents, natural sines, logarithmic sines, natural cosine, logarithmic cosine. That are the tables given in the book. So we have to see the angle for corresponding natural cosines. So theta is equal to 75 degree, 31 minutes. Sixth problem. The resultant of two equal forces acting at right angles to each other is 14 dyne. Find the magnitude of each force. Two equal forces at right angles given P is equal to Q, theta is equal to 90 degree. Resultant R will be 14 dyne. Therefore, R is equal to root of P square plus Q square plus 2PQ cos theta. 14 root of P square. Q and P both are same. So that is also P square. So I can write 2 into P cos theta. At right angles. So it will become 90 degrees. So root of 2P square plus this will become 0. 14 square is equal to 2P square. P is equal to 14 by root 2. 1.414. 1000 Newton. P is equal to 1000. 1000 dyne. Dyne only they have given. So here also writing dyne. Dyne is the olden days, that is CGS system of unit for force. Now we are using MKS or SI. The value, the unit is Newton. Previously in CGS system, the unit is dyne. So this is also dyne. That is also Q because P is equal to Q only given in the problem. Seventh problem. A particle is acted upon by four forces simultaneously. 30 Newton due east. East, west, north, south. 30 Newton due east. Okay, next. 20 Newton due north. 50 Newton due west. 40 Newton due south. So this is the resultant diagram. So 50, this is 30. So net force will be along west. Why this side force is greater? So resultant will be always acting on the greater side. So 50 minus 30, 20 Newton. Similarly, this is 40, this is 20. Net force along south. Q is equal to 40 minus 20. So resultant will be R is equal to root of P square plus Q square plus 2PQ cos theta. So R will be, this is resultant, 90-degree angle, west, south. So R will be root of P square 20 square plus Q square 20 square plus 2 into 20 into 20 cos 90-degree. So cos 90 root of 400 plus 400 plus 0. Root of 800, root 8 into root 100. Root 100 is 10. Root 8 is 4 into 2. So 2 root 2. 2 root 2. 800 will come into 10. 20 root 2. Next, tan alpha q sin theta by p plus q cos theta. What is the value, ma'am? Q sin theta 20 into sin 90 divided by 20 plus 20 cos 90. So you will get tan alpha is equal to sin 90 is 120 by this is 0. -45-degree angle. Tan alpha is 1. So alpha should be 45 degrees. Straight problem. Eighth problem. Two boys raising a load pull at an angle of each other. If they exert forces 30 Newton and 60 Newton respectively, and their effective pull is at right angles to the direction of pull of the first boy, what is the angle between their arms? What is the effective pull? Beautiful question. Two forces they have given, 30 and 60. The effective pull is at right angles. So theta 90. R is equal to root of P square plus Q square plus 2PQ cos theta. P, Q, R, theta. 30, 60. Resultant. You have to calculate. Theta will be perpendicular 90 degree. Therefore, R is equal to root of 30 square plus 40 square 2PQ cos 90. So any value doesn't change. This will become 0. Root of 2500 50 Newton. So tan alpha is equal to Q sin theta by P plus Q cos theta. What is the value? 40 into sin 90 by 30 into This is 140 by 30, 4 by 3, 1.333. So like before, we have to calculate corresponding angle in logarithm book. Effective pull is right angles to the direction of pull of the first buoy. Alpha is 90. Alpha is 90. Therefore, tan alpha, tan 90 is equal to infinity. So what will happen? So infinity is equal to 40 by 30. Okay, so 90 degree. Tan 90 is infinity. So rearrange 30 plus 60 cos theta is equal to 0. 1 by infinity. That 1 by infinity will become 0. 60 cos theta is equal to minus 30. Cos theta is equal to minus 30 by 60 minus half. Okay. Next. Ninth one. Find the angle between two vectors P and Q if the resultant of the vector is given by R square is equal to P square plus Q square. R will be root of P square plus Q square plus 2PQ cos theta. Given R is equal to root of P square plus Q square. So here theta we have to calculate. So square it. P square plus Q square is equal to root will go off P square plus Q square plus 2PQ cos theta. P square plus Q square, P square plus Q square cancels. 2PQ cos theta is equal to 0. Cos theta is equal to 0. Theta should be straight round. Okay. 10th one. Find the vector AB and its magnitude if it has initial point A is equal to 1, 2, minus 1. 1, 2, minus 1. And B 3, 2, 2. So OA vector, OB vector, AB vector you have to calculate. OA is I plus 2j minus k cap. OB is 3I plus 2j plus 2k. AB is nothing but OB minus OA. 3I minus I, 2I. 2j minus 2j, 0. 2k minus of minus, so plus 3k. Therefore, AB is equal to 2y plus 3. Right. Magnitude they're asking. Magnitude means modulus. Root of 2 square plus 3 square. 4 plus 9. Root 30. Magnitude not given means you can write AB as it is. Fine. 11th one. Two forces F1 3I plus 4J, F2 3J plus 4K. What is the magnitude of resultant? R is equal to F1 plus F2. So add 3I, 4J plus 3J, 7J, no K here, plus 4K. Magnitude you have to calculate. Therefore, root of R, magnitude of R will be root of 3 square plus 7 square plus 4 square. Root of 9 plus 49, 58 plus 16. Root of 74 units. 12th one. Find the value of lambda, the unit vector, 0.4I plus 0.8J plus lambda K. Find the value of lambda, the unit vector. Unit vector means magnitude is 1. What is the meaning? Modulus of 0.4 plus 0.8 plus lambda is equal to 1. Unit vector magnitude is unity. So root of 0.4 square plus 0.8 square plus lambda square. So taking square root, lambda square is 1 square 1, 1 minus 0.4 square minus 0.8 square. 1 minus 0.36, 0.64. 0.16, 0.80, so 0.20. 0.16, 0.64 is 0.8, 1 minus 0.8 is 0.2. That is lambda square. So lambda will be root of 0.2 meter. Okay, fine. Next, 13th problem. Prove that the vectors A and B are perpendicular to each other. A vector I plus 2J plus 3K. B vector 2I minus J. Prove A and B are perpendicular. Calculate A dot B. I into 2I plus 2 into J dot minus J. Or you can keep it as it is. I plus 2J plus 3K dot 2Y minus J plus 0. Okay. What is the value? How to calculate? 1 into 2 plus 2 into minus 1 plus 3 into 0. So B will be R. R will be root of 2 minus 2 no root. R let it be plus 0. 0 will be imaginary. A dot B is equal to 0 means A is perpendicular. Right. 14th problem. A force of 7I plus 6K Newton makes a body move on a rough plane with a velocity of 3J plus 4K meter per second. Calculate the power in watt. Force F is equal to 7I plus 6K. Velocity V is equal to 3J plus 4K. Power is equal to formula scalar product of two vectors F dot V 7I plus 0J plus 6K dot 3J plus 4K. So 0I plus 3J plus 4K. 7 into 0 plus 0 into 3 plus 6 into 4. So power P is equal to 24 watts. That's all. 15. If the magnitude of two vectors are 3 and 4, scalar product is 6. Find the angle between the two vectors. Scalar product of two vectors formula. A dot B is equal to modulus of A modulus of B cos theta. Scalar product is 6. A dot B is 6. Magnitude of two vectors 3 and 4. 3 into 4 into cos theta. So cos theta is equal to 6 by 12, 1 by 2. Theta is equal to 1 to 60 degrees. When it is minus half, it will become another rotation. So it should be 120 degrees. 16th problem. If A and B denote the sides of a parallelogram and the area is AB by 2, find the angle between A and B. Area of a parallelogram modulus of A cross B, that is AB sin theta. What are the values given? No value. This is given as AB, or this is formula. AB sin theta is the formula. Given value is AB by 2. AB cancels. Sin theta is equal to half. Theta should be 30 degrees. 17th problem. A cyclist moves along a circular path of radius 70 meter. Radius 70 meter. Okay. If he completes one round in 11 seconds, time is equal to 11 seconds. Find the total length of the path. Total length of the path in circular motion is 2 pi r. 2 pi into r is 70. 140 pi. That is 22 by 7. 2 into 22 by 7. 10. 220 into 2. 440 meters. Second, magnitude of displacement after one revolution. After one revolution, displacement is 0. Because starting point, ending point both are same. Displacement is the shortest distance. So after completing one revolution, starting point here and ending point here same. Displacement is 0. Third, average speed. Average speed will be displacement by time 440 by 11. 40 seconds. 40 meter per second. Average velocity. Average velocity means V average. Displacement by time. Already we have discussed displacement is 0. So velocity also should be 0 because it is displacement by the rate of change of displacement. That is also 0. 18th one. A mail bag is to be dropped into a post office from an aeroplane. Aeroplane, they are dropping a mailbox, mail bag. Flying horizontally with a velocity of 270 km per hour at a height of 176.4 meters above the ground. How far must the aeroplane be from the post office at the time of dropping the bag so that it directly falls into the post office? Actually, when it is dropped, the bag is directly coming into the post office. So what is the distance between these two? You have to calculate. How long? What is the time? Both you have to calculate. We know the formula S is equal to ut plus half at square. Dropped means vertical motion. Vertical motion, u is equal to initial velocity 0, a is equal to g. So half gt square. Half into 9.8 into t square. 176.4. T square is 176.4 into 2 by 9.8. Simplify. This is 18 times 18, so 36. T is equal to 6 seconds. So time we have calculated. How long? What is the distance? How long time taken we have written? What is the distance, the horizontal displacement between the aeroplane and the post office? That is the question. Horizontal displacement. X is equal to horizontal velocity into time. What is horizontal velocity? What are the data given? 70 meter radius. 270 kilometer per hour. 270 into 5 by 18. kilometer per hour into time taken. That should be 6 seconds. So x is equal to, this is 9 means 2 times, this is 9 means 30 times. 30 into 5 into 6 by 2. 15 paisa, 75, 75 into 6, 450 meters. So the distance between the aeroplane and the post office, vertical distance, is 450 meters at the time of dropping the mail bag. Okay, so these are the basic problems related with motion of bodies in a plane. Okay, thank you. We'll continue.